Good afternoon, everyone. Uh, Today we will start again more concepts regarding engineering mechanics. So again, in last lectures we have seen the conditions of equilibrium. We have seen the basics things regarding equilibrium, the various conditions which has been applied, or with the help of equilibrium we can solve the different beam problems we have seen. We have applied the conditions for equilibrium as summation of fx is equals to 0, fy is equal to 0, and moment is equal to 0. Again, with the help of that concept, we have solved the problems related with when forces are applied on a beams. So what are the different conditions? Depending upon the different conditions, we have solved the problems. That is, if there is a condition for hinge support or fixed support is there. So we have solved the problems related with equilibrium. Again, today we will have some more concepts regarding with the mechanics. That is, next is most important is nothing but the frictional force or friction. So friction is nothing but the resistance to motion. In simple words, is nothing but the resistance to motion. So when a force it has been applied, there is a resistance to the movement of the force. When a force it has been applied, here there is a simple example. Here it has been given. When a pushing force it has been applied to, then therefore this it will move in rightwards, and the frictional force will be acting on opposite directions. Okay, when it has been moving in the forward directions, frictional force will be acting on in opposite directions. So such in this we have to find out the frictional force. In some cases we have to find out the coefficient of frictions also, or in some cases we have to find out the resultant. Okay, so frictional force or friction is nothing but, in short, resistance to motion. Okay, in some cases friction is very important. In practical cases also friction plays an important role, without frictions in many cases, if we are in case of moving vehicles, friction plays an important role in order to apply the brakes, and also in many cases friction plays an important role. Okay, so today in today's lectures we will cover some more topics related with the frictions, or related with the center of mass, and related with the internal forces. Okay, we will cover some more little bits related with the mechanics. Okay, friction force. So here, what is frictional force? Friction is a force that opposes motion between the two surfaces. So here, these are the two examples. That is example number A and B. If the resistance is less, that means there is more sliding is there. In case of this, that is object first, example first. Whereas in this case, if there is when the resistance is less, or there is when the frictional force, when the friction is more, that means the sliding of the body it is less. Okay, the friction is a force that opposes motion between the two surfaces. These are the two examples in this case. That is 1 and 2, that is A or B. These are the two simple examples of the frictions. Again, frictional force or friction occurs between the surface of any object is rough. When there is a rough surface is there, then friction occurs. If the surface is smooth, then there is a little friction is there. When depending upon the surface, the frictional force or the coefficient of frictions will be different. Okay? The friction occurs between the surface of any object is rough. Even surfaces that feel smooth are covered with a microscopic hills or valleys. Okay? So here there will be a friction when it has been moving towards right direction of motion, or attempt to direction it has been in rightwards. The frictional force that will be applied in opposite directions. Okay? So here there may be there small it has been described here. Again, frictional force, applied force, it has been applied in these directions. When two surfaces are in contact, the hills and valleys of one surface sticks to the hills and valleys of the other surface. We are applying a force in the rightward directions, and this frictional force or opposition force, it has been applied on reverse directions. Okay, so this there is a broad in this way, there is a broad concept here, because applied force it has been moving towards right, and due to which there will be a frictional force which has been acting in the opposite directions. Okay, again these are the various concepts. The amount of frictional depends on these two factors, the amount of frictions, it depends upon the roughness of the surface, whether it has been a rough surface or whether the surface it is smooth, or what is the coefficient of frictions. We will see the coefficient of frictions also. The concept of coefficient of friction we will also see. The roughness of the, it depends upon the roughness of the surface, and also it depends upon the force which has been applied, the force pushing the surface towards. Okay, so it depends upon the surface, and it depends upon the how much force it has been applied. Okay, if we are moving this object right side, then the friction will be, it will be in the opposite direction, that is in the left side. Again, it depends upon the surfaces, that is the smooth surface or rough surface. Will the tube roll less over the smoother surface, or on the rougher surface? These are the two examples. When there is a smooth surface, the way it will have less frictions, wherein it is a rough surface, it is there, then it will have the more frictions. Okay? Again, these are the examples for this. If there is a block in which it is having a weight of 100 pounds, whereas this block it is having a weight of 40 pounds. Therefore, in this case, both are applied with the same force it has been applied. But here, due to this more weight, there will be the movement of this, or the block will be moved in less in left right directions, and the frictional force will be applied in right directions. Here it has been in left directions, therefore frictional force will be applied in right direction. Same in the case of this 40 bonds. The more the load will be there, the more will be the frictions. Okay. The friction factors review, it depends upon again the same roughness. The rougher the surface, the more hills and valleys there are, and the greater the frictions is there. Force pushing together, or the weights, force increases, the hills and valleys will be in closer contact, and friction will increase. The more the force will be there, or the more the weight of the block will be there, the more will be the frictions. Okay, so it will be dependent on the force which has been applied. Okay? It depends upon the weight of the block also. It depends upon the pushing force of the, on also the weight of the block. Okay, so here it has been taken as pushing force as well as the weight of the block. Okay, so when weight of the block it is more, then in this case friction will be more. Again, there is an example for the surface. The amount of surface area affects the frictional between the objects in liquid and in the gaseous state. Okay. So here, when the weight of this body it has been more, the frictional force will be increases. When the weight of the body is less, then the frictional force will be less. Okay, in case of fluids. Again, surface area and fluids. The amount of surface area affects the friction on a moving object under the following circumstances. That is nothing but the air resistance, such as the size of the parachute. Again, the resistance of an object as it slides through the water, such as a boat. So it depends. Again, in air resistance will be there, depending upon the size of the parachute, or depending upon the boats, whether it has been moving over the water. The resistance of an object as it slides through the water, such as a boat. Okay. Again, when a frictional here it is moving downwards. Okay, here there is a sloping side is there, in which object is moving with the help of its own gravity. It is been moving downwards. Okay, therefore the frictional force will be in opposite directions. If, it is by the weight of its own, by its own weight, it has been moving downwards. Okay, so here the frictional force will be in opposite directions. There is an inclined plane is there. The amount of surface area in the contact usually does not affect the friction between the two solids. Okay. Larger surface areas have more contact, but the pressure between the two is lesser than the increase in friction area is offset by the reduction in the pressures. Okay. So here is a simple example here, in which inclined plane there is a block in which due to the gravity it will be moving downwards, but there will be friction in the upward directions. In the opposite direction there will be a friction created in the opposite directions. Again, what are the different types of frictions? Types of frictions is nothing but the sliding. One friction type of friction is nothing but the sliding. Next is the fluid or rolling and static. Okay, so these are the various types of the frictions: sliding frictions, fluid frictions, and rolling and static frictions. Okay. We'll see what is sliding frictions. Sliding frictions is a friction force that opposes the direction of motion of an object that occurs when solid surface slides over one another. Okay, so sliding friction is a friction force that opposes the direction of motion of an object through that occurs when solid surface slides over one over one another. Okay. So example for this is nothing but a writing pen, that is nothing but the pencil point and paper. Next example is combining your hair, surface of the comb and strands of the hair. So these are the sliding friction is there. A little bit the intensity of the friction in this case is less as compared to the different next friction. Okay. In this case, the frictional the resistance to the friction or resistance caused in this case is less as compared to the different. Again, the fluid friction is there. The forces or the force that tries to slow objects down when they moves through a liquid or a gas. So it is known as a drag or air resistance. When the force it has been moving to downwards, the force that tries to slow object down when they moves through a liquid or a gas. Okay, this is nothing but the air resistance. All gases and liquids are fluid. Fluid friction increases as the speed of the object increases. The fluid friction will be increased as the speed of the object will be increasing. Okay? And airplanes and a swimmer both experience fluid frictions. In this case, both will experience the fluid frictions, whether it is an aeroplane or a swimmer. Both will, whether it is moving in the air or swimmers. Both will have the same frictions. Both will occurs. The same friction will be occurs. Okay. Again, the next type of friction is nothing but the rolling frictions. Okay. So rolling friction is a friction that occurs between the surface in motion that are rolling in which one of the surface is a wheel, a roller, or a ball. Okay. Here, rolling friction will also be here. Here, there is a simple example in which what here the simple example for the rolling friction it has been given. The examples for this is nothing but the riding a bike or tires on ground and whereas bowling or ball and lane. Okay. So this is nothing but a simple example for rolling frictions. Okay. And this is again a type of friction in which the simple example is for rolling frictions. Okay. Again, this is nothing but the static frictions. Again, next type of friction is nothing but the static frictions. So, static friction is nothing but static friction is a friction that occurs when the surface in contacts are at rest. When the surface are at rest, here there is a pot in which it is at rest. Okay, it is rest over the table. Therefore, it is on rest. The static word relates with the when there is no motion. Okay, this table it is at rest, whereas this pot is also at rest. Therefore, again there will be a slight friction will be occurring when both the bodies are at rest. Okay, when the body is at rest. Okay. So static friction is a friction that occurs when the surface in contacts are rest, not in motion. The example for this is nothing but again a book resting on a desk or a potted plant sitting on a sidewalk. Okay. So there is the simple example is there for the static frictions. Again, ways to reduce the frictions are the different ways in which we can reduce the frictions, because I've already said there in some cases we have to reduce the friction and in some cases we have to increase the friction. Okay, depending upon the requirements, in some cases we have to reduce the frictions and in some cases the friction it is to be must or we have to increase the friction. Okay, so what are the different ways to reduce the friction? What are the different ways in which we can reduce the frictions? Okay. So smooth the surface, less hills and valleys, and their need as deep. Okay, when the surface is smooth, the friction will be less. When the surface will be hard, or when the rough surface will be there, then the friction will be more. Okay, so here we can provide a smooth surface in order to reduce the frictions. Okay, we can lesser the hills and valleys. We can reduce the uneven surfaces in order to reduce the frictions. We can reduce the uneven surfaces. Okay. Again, next is nothing but next point is number 2 point is related with the friction is nothing but we can replace sliding with rolling or use wheels. Okay, instead of sliding we can roll in order to reduce the frictions. If we are sliding, there may be more the friction caused will be more as compared to rolling. Therefore we can change its state from sliding to rolling. Okay, if we are having a rolling, in this case the friction will be less as compared to the sliding. Okay, when the body is sliding from one place to when body is sliding, then it will have more friction as compared to the rollings. Okay, again third point is nothing but We can add on lubricants like oil or wax or grease, fills in the hills and valleys. We can use the frictional lubricants or the material which reduces the frictions. So we can add the different materials, okay, such as oil, wax, or grease. This can be filled or this can be used in order to reduce the frictions. Okay. Again, fourth point, last point related with how to reduce the friction is nothing but less force pushing together. Okay, the hills and valleys are not pushed together as hard, so they have less contact. Okay, when lesser force it has been applied, that means less friction will be created between the hills and valleys. Okay, in order to reduce the force, when force acting on a body it has been reduced, that means the friction caused between the two bodies will be reduced. Okay, the hills and valleys are not pushed together as a hard, so they have less contact. Again, ways to increase frictions. In some cases, we have to increase the frictions. In some cases, we have to reduce the frictions. So here is the case for when we have to increase the frictions. Ways to increase the frictions. Rub the surface when we have to increase the frictions. Opposite when in last previous slide we have seen how to decrease the frictions. Here we are increasing the friction in by changing the roughness of the surface. Okay. The more the rougher the surface, the more will be the friction. Okay. Rub the surface, more hills and valleys, and there are not are deeper. Okay. To replace rolling with sliding, when we are replacing rolling with sliding, that means we are replacing less friction to we are increasing the friction. So therefore, we are replacing rolling with slidings. Then in this case, we can increase the friction. In this case, we can increase the friction. Okay. More force pushing together, the hills and valleys are pushed together harder, so the hills and valleys are in closer contact. Okay? More force pushing together, when more forces are applied, that means there will be more hills and valleys created in between the two bodies, and the frictional friction caused between the two bodies, when force applied is more, that means friction caused between the two bodies will be more. Okay. Again, these are the simple examples for the frictions. These are the simple ways in which sandpapers it will have some frictions, carpet or gravel it will have again it will have some frictions depending upon the surfaces or which suppose we have to see the sliding surface also and the contact surface, the sliding surface and the object which has been in contact with the surface. Okay, again sandpaper or carpet or gravel, these are the examples for the frictions which will have frictions where, but these are the examples in which it will have less friction. Glass, as compared to this carpet, glass will have less frictions, whereas carpet will have more frictions, or as compared to the sandpapers or ice, it will have the less frictions, and as well as tiles will have the less friction. These are the simple examples for the friction. In these cases, these are the in these three cases it will have more frictions, and in these three cases it will have the less frictions. Again, in some cases, as I've already said, in these cases we require frictions because we have to have. These are the examples in which we require the frictions, such as prevent us from slipping when walking or running. So, if this pavement or if this road it has been properly, there is a frictional material is there. Therefore, this will reduce or this will avoid the slipping of the slipping accidents. Again, this is again while stops a moving vehicle. In order to have a stop, in order to stop the moving vehicles, the surface it should have frictional. The surface should have the roughness in order to stop a moving vehicle. So here friction plays an important role for a moving of a vehicle. Okay? Again, this in this case is static. All these things are static. To have all the objects in its original place, this friction plays an important role. Okay? Here also there is an example for the friction. Again, here matchstick and in order to have lighten the matchstick, again the friction plays an important role in order to produce a fire. Here also, while holding a glass or holding a pen or writing a pen, this friction plays an important role. Okay? Sharpens the nib, in order to have sharpen the nib. Again, friction plays an important. These are the examples in day-to-day life. In these different cases or in these different things, friction plays an important role. Without frictions, we cannot do these different types of works. Okay? The friction in these cases plays an important role. Here again, we will have some more things, some more problems we will solve related with the frictions. Yes. Again, next we will have the problems related with the frictions. We will solve some problems related with the frictions. So these are the frictional force. It has been there. Therefore, as I've already said, what is friction? Friction is nothing but the resistance to motion. The when vehicle or any object it has been moving over other surface, then friction will be caused. Therefore frictional force will be have. So in order to have the friction, some extra force will be required. Okay? So before sliding occurs, the frictional model, friction is just sufficient to maintain equilibrium and prevent motions. Okay? In order to reduce the motion or in order to avoid the motion, frictional force plays an important role. So friction is just sufficient to maintain equilibrium and prevent motion. So this force it should be just greater than the original force. Okay? The force applied, the frictional force applied will be more as compared the friction F. This F max will be it is to be greater than the original force. Okay, the frictional force. On the point of sliding, when sliding occurs, if it has been directly proportional to the surface, so what is the formula for the frictional force? So here we have taken as formula for frictional force as F is equals to mu into R. That here in this case, what is F? F is nothing but the frictional force, resistance to the friction. Frictional force is there. F stands for the frictional force, whereas R stands for the normal reactions. Here we will see in next slides what is where R it is to be calculated, or how R is to be calculated. We'll see next slide. So where F is nothing but the friction, and R is the normal force or the normal to the contact surface, and mu stands for sorry, here it is mu. Here mu stands for the coefficient of frictions. Here mu stands for this coefficient of frictions. Okay. Here it is actually this. Mu stands for a coefficient of frictions. Okay. Here mu stands for the coefficient of frictions. What is the formula for the friction? That is F is equals to mu into R, where F is the force of frictions and R is the normal contact surface, force on the contact surface, and mu is nothing but the coefficient of friction. This mu stands for the coefficient of frictions. Okay. So with the help of this frictional force, or with the help of these equations, we have to solve the problems. We will solve the problems related with the frictions. The next slide we will solve the problems. Okay, these are the simple problems for the frictional force or frictional problems is there. This is an example for the friction. Again, if there is a coefficient of friction, it has been given as zero point 0.4. If mu is nothing but equal to zero point 0.4, will the block moves? So if the coefficient of friction is zero point 0.4, and whether this block will move right side or it will not move. Whether depending upon this coefficient of frictions, what will be the resistance to motions? Okay, resistance to motion. We will have the resistance. What is the maximum force required for its motion? Okay, here 15 Newton force it has been applied on this block. What is the weight of the block? Here the weight of the block it has been 5 kgs, and it has been kept on a table. Okay, so whether with the help of this 5 Newton it will move right side or not, we will see. So depending upon this coefficient of friction zero point 0.4, we'll see whether this 15 Newton it has been sufficient to move the 5 kgs block right side, or it will not move. Okay, because we have to see whether this 15 Newton it has been sufficient to move this 5 kgs block right side, or it will not move. Okay, so what is the smaller force that will make the box slide along the table? So we will see what is the smaller force which will results to slide the block. So okay. Again, this we have drawn the FBD for this. Again, we have already seen or we have already discussed in last lecture what is FBD, free body diagram. After releasing the supports, or after releasing all the contact surfaces, we have to draw a diagram which is nothing but the free body diagram. Okay? Therefore, we have to draw this free body diagram for this block, in which here is the block and it has been kept on this table, whereas 15 as it is for this 15 Newton it has been acting as it is here, and here there is a contact surface. So here perpendicular to this contact surface we are applying this resultant force. Okay? Instead of this downward, it has been shifted to upside. So here frictional force will be applied. Okay? Here frictional force will be applied in contact with this block and the table, okay? So there is a resultant force, or the normal force which will be perpendicular between the two contact surfaces. Okay, Here this R, it has been actually here, but it has been transferred upside. What about the weight of the block? Here weight of the block is nothing but the 5 kgs or 5 grams, one and the same. Okay, it is 5 kgs or 5 grams, it is one and the same, it is 5 grams. Okay, the weight of block is nothing but the 5 grams. Okay. So here vertical force, it has been balanced, summation of Fi is equals to 0. Again in these conditions, again in this problem, we can use the condition of equilibrium also. Okay, the condition of equilibrium will be used in more most of the cases. In most of the cases, we have to use the condition of equilibrium. So here we will use the condition of equilibrium in order to solve this. So here 5 grams, it has been it is by the self weight, it is moving downwards. So here downwards is there. Again the result, normal force will be acting here. Instead of this, here it has been transferred here. So by you and there this 15 newton, it has moving this block right side, and this F stands for the frictional force. Okay, this F stands for the frictional force, which will resist the motion, so we will see whether this 15 newton it has been sufficient to move this block. So this F stands for the frictional force. Okay, so it is in opposite directions. It will be in the opposite directions. Okay, so here vertical force or vertical normal reactions is R is equals to 5 grams, which has been acting downwards. Now, what about frictional force? Maximum possible frictional force is nothing but F max is there. What is the formula for this? Maximum force, mu into R is there. That is the frictional coefficient of friction into the normal reactions. R is nothing but the normal reactions, which is perpendicular to the contact surfaces. R. What about the value for the mu coefficient of friction? It has been given as zero point 0.4. What about R? R, it has been given as vertical reactions or vertical force. It has been given as 5 grams. Just it is simple multiplication is there. Zero point 0.4 into 5 grams. And what about 5 G? G stands for again the acceleration due to gravity. What is the acceleration due to gravity in this case? It is 9.81. Okay, 9.81. We are multiplying this 5 into 9.81. So it comes to be 19.6 newtons. It comes to be 19.6 newtons. Okay. The pushing force or the resistance or the force of friction in this case is nothing but 19.6 newtons. Okay. The pushing force is less than 19.6. That is a 15 newton pushing force. It is less than 19.6. Therefore, this block cannot move left side. Okay. The block will not move. Okay. Due to this 15 newton load, the block will not move towards left. Okay, because 19.6 it is more as compared to 15. Okay. If it is suppose this given value is 20 or 21, 23, that means it can move right side. Okay. In present case this 19.6 is more, therefore it will not move towards left. Okay. It will not move towards left. The next again example, there is a simple pulley examples in which block example is there, in which there is a smooth pulley is there, and you have to move this block that is having a 400 grams is the weight of the block. Again it is moving with the help of this 200 grams, that is the weight. Okay, with the help of this hanger, it has been it is to be this block, it is to be moved. This is a simple example as a crane is there. We are moving a block with the help of this 200 kg grams. Okay. If the pack in is on the point of moving, find mu. We have to find out mu. What is the coefficient of friction in order to move this block? Okay, we have to move this block. So how much should be the coefficient of friction? How much the surface to be made, or what the surface to be made, or what will be the mu for this surface in order to move the block right side? Okay, due to this 200 newtons, we are moving the block right side. So what is the amount of the surface coefficient of friction for this surface will be required? Okay. So here again we have drawn free IBD for this. Here again we have drawn, we have transferred here IBD for this. There is point. This it is acting downwards. So here we have taken as zero point 0.8, which is acting downwards. Again there will be a normal reactions which is acting upside. So here there is a normal reactions up. If we are cutting a rope, this smooth, it has been tied with a rope. So after cutting, there will be a tension here. There will be a tension created here. So here tension will be away from the point, whereas it is moving right side. What is the frictional force? It is moving left side. Okay, because due to this block it is hanging here, it will move right side. So therefore this it will have in reverse direction. We will have this in reverse direction. Okay. Again, on the point of moving, F is equals to, again, the for how to find out the force of frictions. First, what is the summation of Fi is equals to, again we have to use the condition of equilibrium. Summation of all y components is equals to 0. Here y component is the weight, that is 0.4 grams, and vertical component is r. So what is r is equals to, r is equals to 0.4 times g. It is simple. That is balancing is there. Here weight, it has been balanced by this reactions, therefore r is equals to 0.4 g. On the point of moving, what is the frictional force? Force, it has been moving. F is equals to mu into r. Mu, in this case we have to find out. What about r? R we have calculated as, we have taken this r as 0.8 grams. Okay, here 0.8 grams is r. What about this t? Again, here we have taken the condition of y. Again we have to take the condition of x also. Okay, summation of fx is equals to 0. The summation of fx is equals to 0. That means right side it is equals to left side. Right side is equals to left side. That is f is equals to t. Next is as the pulley is smooth, therefore T is nothing but equals to zero point 0.2 grams. Here we have taken this 0.2 grams. That is what is the weight? Again, while breaking this, again it is moving downwards. Therefore, there will be a tension here in upside directions. So after applying this, or this T is equals to summation of Fy. Again, it is to be applied to this 200 grams. So here, while cutting this 200, it is moving downwards, and it again tension will be created here, and it will be in upward directions. Therefore, summation of Fy is equals to zero point 0.2 grams. So T is equals to zero point 0.2 grams, and this will be equated with this zero point 0.2 grams. So zero point 0.2 grams. Here, what is F? F we have taken as mu into zero point 0.4 times G. Mu we have taken here. Just we are equating this. There is F is equals to T is there. This F is equals to T. What about F? F is the value. It is having a value of mu into zero point 0.4 times G. What about T? T is having a value of zero point 0.2 G. So mu, that is multiplied by zero point 0.4 g, that is equals to 0.2 g. After cross multiplications, mu comes to be 0.2 g divided by 0.4 g. That is after divisions, it comes to be 1 by 2. That is mu is equals to zero point 0.5. Mu comes to be zero point 0.5. Here we have taken force of gravity as 9.81. Again the same thing, 9.81, or there is no use of this g. This g get there is acceleration due to gravity, it has been cancelled. So mu comes to be 1 by 2, that is zero point 0.5. So how much mu will be required in order to move this block over this, or in order to lift this block, or to move this block? How much mu will be required? Mu will be required as 0.5. Okay, mu is equals to 0.5. Again, there is a different problem is there related with the frictions. Again, the some different concept, it has been taken care in this related with the frictions. Again, before this, we have to keep in mind the various equations related with the motions. Okay, again we have to see, according to Newton's second law, these things, it is to be kept in mind related with the frictions also. Okay, so we'll have a little bit concepts regarding this. Already we have discussed this Newton's second law. That is nothing but the resultant force is equals to mass into acceleration. That is m into a. Already we have discussed in previous lectures. What is Newton's second law? Second law is nothing but force is equals to mass into accelerations. Whereas the force is in newtons, mass is in kgs, and acceleration is mass per second square. So it has been taken as second raised to minus 2. That is meter per second. Meter per second square. Okay. What about the displacement? Displacement we are having according to equation of motion, or equation of displacement. What is the equation of displacement we have taken as S is equals to initial displacement we are considering as u, whereas final displacement we are considering as v. Okay. So initial displacement plus final displacement multiplied divided by 2, that is the average displacement multiplied by the time. These are the equations for the displacements. Okay, in order to find out the equation for displacement is nothing but initial velocity plus final velocity divided by 2. It has been multiplied with the time. Okay. Again, according to the equation of motions, again we are having the equation as v is equals to u plus at. This equation is again useful for calculating the thing when the concept of friction we are applying. Again, this displacement, or this v is equals to u plus at concept will be used. Again, for this s is equals to ut plus half at square, where s is again stands for the displacement. U stands for the initial velocity. T stands for time. Again, half acceleration. T square. All these are the equation of motions. Okay, S is equals to ut plus half at square, and v square is equals to u square plus 2s. Now, these are the equations of motion in a straight line with constant acceleration. Okay. Where u is nothing but initial velocity, v is nothing but the final velocity, a stands for the acceleration, and t stands for time, and s stands for the displacement. So this concept, with the help of this concept, again, we will solve the problem. One problem, actually, this concept we have taken care, because we have to solve the problem related with this. So we'll solve the problem related with this concept. Okay. Again, there is a car which is having a weight of 1.2 tons, and it is moving left side, okay, with a velocity of 20 meter per second, okay, meter per second. So it is moving left side with a velocity of 20 meter per second, and 20 meter per second. And what about its weight of this vehicle is nothing but 1.2 tons, okay. The car brakes sharply, then skids. If mu is equals to zero point 0.8, then we have to find out these two things of this, depending upon this. Okay. First, we have to find out its accelerations, and next we have to find out the distance traveled in coming to rest. Okay. What are we have to find out the distance travel, and we have to find out the accelerations also. These two things it is to be find out. Okay. Acceleration and the distance travel. First, how to find out? So first, we will draw the FBD for this car. Here, the weight of this car is nothing but 1.2 tons. That is equals to 1200 grams. Okay, we will convert this into grams. So we have converted this 1.2 tons into grams. So it comes to be 1200 grams. Okay, it is moving left side. So left side, there is movement of this vehicle left side with a velocity of 20 meter per second. So what is the frictional force? Frictional force will be applied in right side. Okay, frictional force will be applied in opposite direction, so right side. Okay, as this car, it is in contact with the surface, therefore there will be a reactions here. We will transfer reactions here, and reactions will be transferred upside. Okay, after having this, it will be transferred to the upside. Okay. Again, what is the frictional force? Frictional force here is nothing but F is equals to mu into R. That is, the mu stands for the coefficient of frictions. R stands for, again, the normal reactions. Here, but in this case, mu, it has been given as zero point 0.8. So we have taken this as zero point 0.8. What about the reactions? So summation of Fy is equals to 0 by concept of the, again, by the considering the condition of equilibriums. Fy is equals to 0. So Fy is equals to 0. Therefore, vertical reactions is this R is positive, whereas 1200 grams is negative. So there, after equating, it comes to be R is equals to 1200 grams. So the R we have taken as 1200 grams. So F is equals to mu into R. Mu we have taken as zero point 0.8 into R we have taken as 1200 G. G is nothing but, again, gravity. It has been taken as 9.81. That is, again, meter per second square. Okay. So just we have multiplied this. After multiplying this, zero point 0.8 multiplied by 1200 into G, that is the value of 9.81. It comes to be 94. That is 9408 newtons. The force, frictional force, which results in opposition of this moving of the vehicles, is nothing but the frictional force caused is nothing but 9408 newtons. Again, this again, Newton's second law. What the Newton's second law says, it has been in opposite direction. Therefore, F we have taken F is equals to force is equals to mass into accelerations. The force we have taken as force is equals to mass into acceleration. So here frictional, it is taken as negative. Therefore, minus 9408. That is equals to force is equals to mass into accelerations. Here mass, it has been taken as 1200 into area, into accelerations. So after cross multiplications, accelerations, it comes to be minus 7.84. Again, its unit is meter per second square. Next, what is the thing we are using? The next we have to calculate is nothing but the distance travel. How to find out the distance travel with the help of this acceleration, or with the help of this velocity? How to find out? So we are having two terms, that is the accelerations, and we are having the initial velocity. Initial velocity. So with the help of this initial velocity and with the help of this a, we can find out the distance travel. So again, the equation used is nothing but v square is equals to u square plus 2s. Here, what is the question in question? Here, after applying brake, the car, after some time, it will stop. The final velocity in this case is nothing but 0. So here v square, Here final velocity we have taken as 0 square. The final velocity in this case will be 0. What about initial velocity? It is given here as 20. Okay, so 20 square. Again, this acceleration we have taken as minus 7.84. So 2 multiplied by minus 7.84 and multiplied with s. What is s? S we have to calculate here. So s is in this case is nothing but distance. So distance we have to calculate in simple. There is rule simple multiplication division is there. So s after equating it comes to be 25.5 meters. Okay, so here we have used the three different equations. There is v is equals to ut plus half at square. We have used v square is equals to u square plus 2s, and these three equations of motion, equations of displacement or motion, it is very important for solving the problems. Okay, so in this slide we have solved the problem related with the, again it is having solve the problem related with the frictions. Okay, again we will have some more problems related with this. So again we will have some more problems related with this. Yes, so we will have this concept as again the different concept. We have solved the problems related with frictions. Again we will have this concept of center of mass. Okay, because in today's lectures we will cover the things related with this. We have covered frictions. We have seen the problems related with the frictions, and also we will discuss about the this center of mass also. Okay, so this center of mass. Okay, then what is center of mass? The point at which the point of an object at which all the mass of the object is assumed to be concentrated. Okay, the point at which the whole mass is supposed or it has been assumed to be concentrated. The point at which whole mass is, it is supposed to be concentrated. If we are considering as the center of mass. Okay, the center of mass is nothing but the point at which the point of an object at which all the mass of the object is assumed to be concentrated. All the mass of the object or block, it has been assumed to be concentrated. Again, what is the point? The point is, this point is called a center of mass of the system. It is the balancing point for the mass distribution. The point at which it is the balancing. Okay? By designing that point or by identifying that point, we are considering that whole mass or whole thing, it has been concentrated or it has been assumed to be accumulated at the same point. Okay? For balancing purpose. Then what are the different points to be considered related with the center of mass? The points to be considered related with the center of mass is nothing but if the net external force on a system of a particle is zero, if the net external force acting on a block or acting on an object is zero. So if the net external force on a system of particle is zero, then even if the velocity of individual objects changes, there is a point associated with the distribution of object. Okay, so that means if the external force acting on the body is zero, even though there will be a point created. Okay, if there is external force is zero, that means there is no as such force acting on a body. Even though there is a point which is referred to as the that point will have some motion, and that point will have the center of mass. Okay, even if the velocity of the object of the individual object changes, there is a point associated with the distribution of object that moves with zero. Okay, acceleration, this point will be moving. That point is nothing but the center of mass. Okay, even though there is no external force is applied, there will be movement of the there will be a movement of the there will movement of the object. Okay, with a zero acceleration, there will be a small movement in the object. Okay, again center of mass. So here there is an example for this. Here while throwing this, there is the line along the same line of actions, or there is along the line there will be a center of mass. Okay, the center of mass will lies along the central axis. That is nothing but the axis of symmetry. We are dividing this here. This axis of symmetry or this parabolic shape is nothing but the center of mass. Okay, this is an example for this. Here this the center of mass will be taken care. Okay, therefore, the center of mass will lies along the central axis, the axis of symmetry. Here, it will be acting along the axis of symmetry. Okay. Again, and it is center of mass that it will follows the line of a parabola. It will follow the line of parabola. In this, it has been depending upon the different objects. Here it has been in the parabolic shape. In some cases, it will be in different shape also. So here, while throwing this, the shape it has been taken care is nothing but the parabolic shape. Okay? So along the same line of action or along the same axis of symmetry, here it has been caused along this parabolic shape. Okay? It has been taken care in along the center of mass. It has been taken care in the along the parabolic shape. Okay? Again, what are the different things in order to this calculate the different points related with this? So here, depending upon this. Sorry. Center of mass, here there are m1 and m2. These are the two masses. In this case, it has been separated by distance d. So here we have to here we have to find out the distance, cumulative or combined distance. So combined distance in this case, how to find out when it has been separated by distance d? M1 and m2, these are the two objects, or these are the two masses which has been separated by distance d along x and y axis. We have drawn this along x and y axis. Okay, and we have to find out the center of mass. Okay, center of mass for this. What is the distance for the center of mass? We are considering the mass to be accumulated or assumed to be taken care. Okay, the x combined distance for this in the x combined, it has been taken as is equals to, here two masses is there, so 2m into the distance separated by this and divided by m1 plus m2. These are the two masses m1 and m2. Now again, if these are the again the different cases for this. Now from this, we can see that if m2 is 0, if this second block is not available, this second mass is not available, so then what will be the value of for this x combined value of this x? It will be 0, because this we are calculating along this, and this m1 it is along x and y axis starting point. That means m1 is already 0, m2 is not taken care. If m2 is not present, that means this x the combined distance for this from along the x-axis will be 0. So therefore this will be 0. Similarly, if m1 is not taken care and m2 is available, I think m1 is not taken care, that means along this axis it is not taken into consideration, but m2 is available. There is a m2 mass, it has been available, and it has been separated by distance of d. So there, then x distance for this along this x and y axis will be d. Again, finally, if m1 is equals to m2, then if m1 that is what is m1 is equals to m2, what will be the distance? The distance will be the half, because we are assuming at the centers. We are taking at the centers. Therefore, if m1 and m2 are available, that means it will be at the center. That is equals to d by 2. Okay, half of d. So we can see that the center of mass in this case is constraints to be somewhere between x0 to xd. All the mass, it is to be constant, or it is to be assumed at some distance. Okay, because these two in between, because this m1 is also available, m1 is equals to m2, therefore mass will be in somewhere in between these two masses. Okay, it has been taken as d by 2. Again, center of mass for this case, again, if this m1 it is it is not at the same axis, x and y axis. Okay, it is having some distance, so we are taking this distance as x1. So at some distance, we are assuming that m1 it has been situated at some distance x1, whereas m2 we are assuming at a distance of x2 from this x-axis. Okay, we are assuming this m2 at a distance of x2. Okay, again the distance separating the two m1 and m2, we are finding out this d. Okay, so instead of in previous case, we have taken this m1 at the axis x and y axis, but here it is having some distance, that is x1, and also from this axis m2 is separated by a distance of x2. What about the distance between the two blocks or two masses? Intermediate distance is nothing but small d. Okay, so here is again the different case for the center of mass. What will be in this case? So here, according to this center of mass, what will be the center of mass, command center of mass, or the distance for this? So m1 into its distance, so m1 is the mass, and 2 into its distance is nothing but x1 plus m2, and into its distance about the axis. Okay, so x2 is the distance of this m2 about the axis. So m2 upon m2 into x2. What are the difference? Divided by m1 plus m2, divided by the combined or the total mass taken care. Okay, the m1 plus m2 is nothing but the total mass. Now, note that if x1 is equals to 0, that means x1 is equals to 0. We are back to the previous equations. If x1 is 0, that means m1 it is acting at the starting point. That is the previous case. Okay. Here, if x1 is having the value, then this will be the conditions. Okay. If this m1 it has been starting at the starting point, it has been starting at the x and y axis. That means it will be the previous conditions. Okay. It will have the previous conditions. Again, if number of masses are there, we have seen one mass, we have seen two masses, and if number of masses and it is having some x1, x2, x3 and x4 and so on the distances, what will be the center of mass or the distance for the center of mass? So m1 x1 plus m2 x2 and so on up to m1 mn and xn, and divided by the total mass. What is the total mass in this case? So m1 plus m2 and so on up to the n. Okay. So here, when number of masses are acting, what will be the center of mass for the all the different masses separated by distances? So here, this is the simple equation is there, simple formula is there in order to calculate the center of mass. Again, the same case we have summation 1 upon m we have taken common, and 1 to n summation of if we are taking from first to n numbers of number of different masses are there. So m I x it is just the simplified way or the simplified combined formula for this center of mass. Okay. Again, if it is having x and y axis, so here again if it is having x and y axis, so therefore, center of mass can be taken care if it is having x axis. So what will be the center of mass? So x along x directions of center of mass is taken as 1 by m. That is summation of mn xn. If it is having along center of mass, it is taken care in along y directions. So same formula will be there, but it is taken in mn yn. Whereas if it is taken the distance to be calculated along the z directions, so we will have 1 upon m summation of mn into zn. So depending upon the directions, whether it is having in along x directions, whether we are taking in along y directions, so here it has taken into considerations. Okay? Depending upon the directions, it has been taken into consideration. So next is again next important is nothing but the position. Okay. So position or velocity and acceleration of the center of mass, again the same. If it is having some velocities taken care, if it is having in direction distances there, so yeah, we can take x, y and z distances. But if it is having velocity, so same formula will be there. So m1 v1 plus m2 v2 plus m3 v3 upon m1 plus m2 m same. Instead of distances, we are taking velocities. If acceleration is to be considered, for center of mass, here m1 a1 plus m2 a2 plus m3 a3 and so on upon divided by m1 plus m2 plus m3. So in this case, if the distance to be considered, here we can use this equation. If velocity is considered here, in this case we can use the velocity, and accelerations is considered, we can use this as acceleration. Okay. So in this, these are again the important concepts regarding the center of mass. We have seen the center of mass, the basic things related with the center of mass, and also we have seen the concepts regarding the center of mass. Okay. Again, lastly, we will see this problem related with this. Yes. So last is internal forces. Okay, we have seen frictions. We have seen center of mass, and last is nothing but the internal forces. Okay? So internal forces, which are we have already solved these problems related with in equilibriums. So what are the different types of internal forces acting on this? Okay, so there is a simple beam in this case. There is a simple beam in which internal different forces are acting. Okay? So here we have taken in this beam, there is a roller support is provided here, and there is a hinge support. Okay. So how many reactions will be there in this case? So here it will have only one reactions. What about in this hinge? It will have two reactions. If it is breaking in this part, if it has been breaking, the how many reactions will be taken care? Internal forces. Regarding internal forces, how many reactions will be taken place? So here there will be first there will be sliding between the two objects. So here there will be sliding between the two. After breaking, there will be sliding. So vertical forces will be there. Okay? One force will be in downward directions, other force will be in upward direction. These are the internal forces. Okay? Internal forces. After breaking this beam, first this will be in downward directions, and balancing for balancing this vertical force will be applied. Again, there will be a normal force will be there. This vertical will be the sliding force, or this shear will be taken care. After breaking, there will be a shear created here, and after breaking this beam, there will be a normal force will be there. Okay? The normal force again will be perpendicular to this. This force will be right side, and this force will be left side. Again, there will be a movement here. Anti-clockwise movement will be taken care. Anti-clockwise, and here clockwise movement will be taken care. Okay? So we will find out our the values for this. We will find out the reactions for this. What will be the reactions at point A? Reaction at point C, that is the vertical and horizontal reactions. First we have to resolve this, because this it is making an angle of theta, that is it has been given in the form of slope. So first we have to find out the tan theta, that is tan inverse of opposite upon adjacent. Opposite is 4 by 3. So this in this way we have to first find out the intensity for this 15 newtons, and we will after that we will find out the calculations. Okay. Again, this is here again there is an example for this axial forces. These are the internal forces which are acting here. In case of this block, the axial forces will be acting. Okay. Here in along the same line of actions, there will be axial forces will be acting. Already we have seen in previous year also, we have seen shear force, it has been acting. Here shear force, it has been acting in forward and upward directions. Again, movement will be taken care, that is the sagging or hogging movement depending upon the conditions. These internal forces depends upon geometry of members, and depends upon the loading of members, and it depends upon the location within the members. Again, after breaking this point, it is acting at 2 meters. So here it has been divided into vertical force, and here it has been divided into two forces, the vertical and as well as horizontal. After breaking this, it is having first as shear force in downward directions. Again, here it is having anti-clockwise directions. Anti-clockwise direction movement will be there, and there is a normal force. As there is no horizontal force here, therefore normal force will be 0. So after calculations, we have to use the condition of equilibrium. Fx is equals to 0, Fy is equals to 0, and moment is equals to 0. So in this case, for this only for this small figure, Fy is equals to Fy will be balanced with this vertical reaction, that is 20 Newton upwards. We have to calculate the reactions as it has been acting at center. So this at 6 meters, that means reaction at vertical reaction at A will be 20, and vertical reaction at B will be 20. So here we have taken as 20 newtons as upward directions, which has been balanced by this vertical force which has been acting at downwards. Okay. So here we have taken as Fy according to condition of Fy, V is equals to 20 newtons, and we have to take movements. Okay. We have to take movements. Now the movement taking at this point, the clockwise, here movement about this point is clockwise, 20 into 2, that is 40 clockwise. What about this movement? We have to balance this movement with clockwise with anti-clockwise. So here after balancing this and conversion, it will be converted into anti-clockwise. So here intensity of M is nothing but, and it is taken as anti-clockwise. By balancing this vertical force into distance, we have balanced this, and it has been taken as anti-clockwise as 40 Newton meters. Okay. Again, there is a case. In this case, there is a UDL. Again, we have to convert this UDL, and here there is a breakpoint is there, and we have to find out the internal forces. Okay, internal forces in this case. Okay. Again, this internal forces. First, we have to find out the reactions. Depending upon the reactions, we have to find out the forces. Okay. After solving by Fx is equals to 0, Fy is equals to 0, and moment is equals to 0, here we have calculated the forces. Okay. Here Fx is equals to 0 normal, because there is no as such horizontal force, therefore Fx is equals to 0, and normal reactions will be 0. What about Fy? Fy we have calculated after simplification of UDL, conversion of this UDL into point load. So a point load, it conversion, it is into a point load, it comes to be 100. Sorry, it will be 100. So 20 into 5 is nothing but 100. This will be 100. Okay, this will be 100 Newton meters. So what about the half? It has been acting at center. So 50-50 will be taken, and 50 will be balanced by this vertical force, and this 20 also considered. Okay? So after solving this, V comes to be 10 newtons, and this movement, after this movement taking about this breaking point, this movement comes to be 60 Newton meter. You have to solve this. Simple problem is there. For solving, after solving this, we can easily find out the movement as 60 Newton meters. Okay. Again, this normal reactions. Again, the concept for this same way, the other side it has been taken care. So in this way, the various internal forces acting on a body we have seen. We have to draw. We can draw shear force and bending moment depending upon this also. Okay. So in this way, in today's lectures, we have seen the concepts regarding the frictions. We have seen the concepts regarding the center of mass, and here we are seeing the concept of the shear force and bending moment also. Okay. So shear force and bending moment also it is to be drawn. Depending upon this, there is a UDL in which there is again a roller and a hinge support. We have converted this 20 that is acting at 6. We have divided this and converted into a point load. And depending upon this, first we have to find out the reactions, and then we have to draw a shear force diagram. Okay? It has RAY we have calculated as 60 newtons. That is, it will be moving in upper directions as there is a UTL. Here, a line will be drawn, and we have to use the sign convention for shear force diagram. That is, right side. If it is upward, we have to apply. We have to take downwards. Okay? So after joining this part will be above line will be positive, and this below line will be negative. Okay. So in this way, we can draw the shear force and bending moment also. Okay. So in today's lectures, we have seen the friction and center of mass and the concept related with the internal forces. Okay. So thank you. Today we will end the lectures on engineering mechanics. Some more concepts will be clear later on. So today we will end this lecture. Okay. Thank you.